Right. Bismillahirrahmanirrahim. Assalamualaikum. To recap what we did last session, we saw that rate constant K is not affected by any change in concentration. Okay, only temperature will have an effect on the value. Even so, when temperature increases, the rate constant K increases as well. By how much? We don't know. There is a calculation for that. There is a formula for that, which thankfully, you don't have to deal with, I hope, not for your syllabus. Just to remind you again about this combined effect, combined it. Please be careful with the combined effect, because I still see some mistakes made in your homework. You only looked at that particular reactant that you're interested in, and then you just assume that the other one is not changing. Okay, there's a notification just told me that the internet connection is not stable, and that's really annoying. Please let me know if my audio is not clear on your side. Okay, the next one that we're going to look at is mechanism. Okay, mechanism and the rate equation. Now you already know what a mechanism is. This is an example that you don't have in your notes, okay? But don't worry, because later on you will draw this on the next page, which is page 10. This is a mechanism of SN1 nucleophilic substitution reaction of your halogenoalkanes. Okay, it's something that you should be familiar with. Some of you may have forgotten about this completely because they've already did their AS exam in November last year. Okay, right. So what is a mechanism? Basically, a mechanism is a series of steps through which the reaction progresses. Okay, basically, mechanism shows you how the reactants is transformed into products. So it shows you the movement of electrons, it shows you the breaking of bond, and then in the process there is an intermediate, but later on the intermediate is being used up. That's why you don't see intermediate in the equation. So the equation of a reaction is actually simplified. They just tell you what you start with and then what you end up with. Mechanisms actually tells you what is happening, right? Now, from equation alone, if we look at this equation of a bromo, what is this? 1, 2, dimethyl bromoethane. Okay, so from this, I'm just going to call it haloalkane. Okay, so from this haloalkane, you can, what was I going to say about just now? Remember. Anyway, from this equation, you can see that it looks like it's a one-step process. Reactants to products, done. But actually, the mechanism will show you that it is made up of two steps, or two stages. Okay, it depends on that particular reaction. Sometimes that reaction may involve 3 stages, 4 stages, 5 stages. Okay, and that all depends on the mechanism. Actually, chemists, there is no tool, no instrument that can be used to monitor mechanism. Mechanism is solely something that the chemists come up with based on evidence. Okay, there is no microscope that can show you the bond is breaking, the electron is moving. No, you cannot see it because electron is very, very, very small, and you cannot see the movement of electron from one species to another species. So all this mechanism is something that has been created based on theory by the chemists. Okay, right. So how did the chemists come up with mechanism? Actually, the rate equation comes into play. Okay, the rate equation comes into play. So the rate equation actually tells you which one goes into this step 1, which one goes into step 2, and etc. right? So going back, if all the steps are added together, they will add up to the overall equation for the reaction. Okay, so looking at the mechanism, this is step 1, and then this is step 2. So if you add step 1 and step 2, you will get the overall rate equation. That is how you break down rate equation into mechanisms, or how you add up the mechanisms to get the rate equation. Okay, right. Each step, each stages in the mechanism can have a different rate of reaction. Okay, so if I say the rate of reaction of this particular equation is, say, 10, okay, just a relative rate, that does not mean that each stage has a rate of 10, right? They have different rate. Now, what the rates are is not our concern, but we want to know this particular stage or this particular step, which is the step that actually controls the rate of reaction. Okay, you can have 5 steps or 5 stages, yet you will only have one out of these 5 stages that control your overall rate equation. Okay, so this important step or important stage is called the rate determining step. Again, it's nothing new for you. I have written down RDS in your mechanisms before. I told you, just copy it down. I'll talk about this next time, next year. Okay, so if you look at the mechanism in your organic reactions, you will see that sometimes I label the arrow as RDS, rate determining step. It is quite obvious that this step is the one that controls your overall rate of that particular reaction. Okay, and rate determining step, RDS, is usually the slowest step. Now, I don't know if you've heard of this quote where it says, in a team, you're only as fast as the slowest member in your team. Have you heard of that quote?
No.
No, you've never heard of it?
No.
No, but it's real. Someone has said that to me. Your team is only as fast as your slowest member. Okay, if you may have like all this fast people in your team, but if you only focus on the fast people, your team will not improve. You need to help the slowest one. Okay, so same thing like this reaction. You can have 5 stages, and then you can have 4 out of 5 stages that are really, really fast, and then this one stage which is the hello everything. No, it wasn't me. I don't know what happened. I got disconnected, and okay. No wonder I was like, where is the chat box and where is the participants? You plagiarize people quotes. Oh yeah, maybe. Yeah. Wait, did you guys stay in the meeting when I was away?
No.
No.
You got signed out as well?
Yes.
Oh, okay. It wasn't me, okay? It wasn't me. It was Zoom. Maybe they heard the quote that I plagiarized. Yes, Eric. That's why they disconnected my session. But anyway, okay, back to this mechanism, right? The rate of a particular reaction depends on the rate determining step, okay? It depends on the slowest step in that process, right? Okay, next. So this is just a bigger version of that SN1 mechanism. How do we, how is the rate equation related to the mechanism? Okay, so the particles that collide together in the rate determining step are the substances that appear in the rate equation. Okay, so whatever the rate equation tells you, for example, okay, so if we use this example, rate, you have species X and species Y, okay? Species Y is squared. That means in your rate determining step, X and Y is involved as the reactant, okay? Well, I'll use examples after this so that you can see. If a substance, if your reactant does not appear in the overall rate equation, that means it is not in the rate determining step. Okay, so anyone who appears in the rate equation is the same species that appears in the rate determining step, right? Okay, if there is only one species in the rate determining step, we call this unimolecular. If there are two species in the rate determining step, the species can be atom, ion, or molecule. Okay, if there are two species in the rate determining step, we call this bimolecular. Okay, unimolecular means one, bi means two. Now, if you look at SN1, okay, SN1, the number one means that it is unimolecular. There is only one species in the rate determining step. Okay, let's have a look at example. And then hopefully after example, we can go. Right. So for these examples, I know I'm still using the general one, A, B, C, D, E. So you can see that the reactants are A, B, C, A, B, and C. What? Who's shouting? Is anyone shouting? Am I shouting? Does it sound like I'm shouting at you? I'm not. Okay, right. Lisa shouting. Okay, going back to the slides, a lot of distraction. Reactant A reacts with 2 moles of reactant B plus reactant C to form product G and product E. Okay, so the overall reaction is that the overall equation. The mechanisms are actually a 3-step or a 3-stage mechanism. Okay, step 1, you have first the A reacting with B to form an intermediate X plus D. Okay, now you notice that this X does not appear in your equation. This is why we call it intermediate. Anything that does not appear in the overall equation is intermediate. Okay, the reason for this is because the intermediate will be used up in the next stage, right? And step 1 is the slow step. So that is the rate determining step. Okay, step 2, your intermediate X reacts with C to form a Y. Now you see that Y is not in the overall equation again. Y is again another intermediate. Okay, but it reacts further with B to form E. Okay, so if you add this all up, A plus B plus X plus C plus Y plus B equals to X plus D plus Y plus E. Your X's cancel out, your Y's cancel out, B plus B becomes 2B. So you have this overall equation. Okay, I hope you can see that, because if I were to type this down, it would be very, very long. Just put everything, all of your reactants on the left side, and then all your products on the right side. You can see that you can cancel the X, you can cancel the Y, the B will be 2B. So that gives you the overall rate equation. Okay, sorry, rate, not rate, it gives you the overall equation, sorry. Okay, so the rate equation, now this is the rate equation. Rate equation is equals to K times A to the power of 1, B to the power of 1, C to the power of 0. Okay, C to the power of 0 is the same as nothing. Okay, just imagine that it's not there. Okay, now you see that in your rate equation, you have A and B. So as I said, whatever species that appears in your rate equation will be in the slow rate determining step. Okay, C does not appear in the rate equation, so C must appear in the other steps that are fastest. Okay, fast. So C appears in step 2, as you can see in this mechanism. Okay, C is 0 order as it appears in the mechanism in a fast step after the slow step. Your X is the intermediate as well as your Y. The slow step does not involve C directly. X is an intermediate derived from A and B reacting together. And this reaction or this mechanism is called bimolecular because in the slow rate determining step, there are 2 species reacting with each other. So this is a bimolecular mechanism. Okay, is that clear?
Yes.
Okay, moving on with the next example. Example 6. We have nitrogen dioxide reacting with carbon monoxide to form nitrogen monoxide and carbon dioxide. Okay, so this reaction is made up of 2 steps. Okay, the first step is where you have your nitrogen dioxide reacting with your nitrogen dioxide to form nitrogen monoxide and nitrogen trioxide. Notice that this nitrogen trioxide is not in your overall equation. That must mean that it's a intermediate. Okay, but don't worry, the intermediate will be used up. That's why you don't see it in the overall equation. Okay, now it appears that step 1 is the slowest step. So that means step 1 is the rate determining step. R, D, S. Okay. And as we know, RDS, we are only interested in the reactant. These 2 reactants are the one that appears in your rate equation. So if you look at your rate equation, rate is equals to K, which is rate constant, times by 2 lots of nitrogen dioxide. That's all you have. That's second order. Okay, because you have 2 molecules of nitrogen dioxide reacting with each other. That's why it's second order. Okay, carbon monoxide, which is the other reactant in this equation, does not appear in the slow step. It appears in the fast step. That's why you don't see it in the rate equation. This reaction or this mechanism is again a bimolecular because in the slow rate determining step, there are 2 molecules colliding with each other. Any question?
No.
No, okay, moving on. Clear drawing scheme. Next example, example 7. The reaction 2N2O5, okay, react with each other to form 4 molecules of nitrogen dioxide and 1 oxygen molecule. Takes place in 3 steps. Which step is the rate determining step? Okay, now they do not tell you which step is the fastest or the slow, which step is the slowest. Okay, essentially the rate determining step is the step that is the slowest, right? They don't tell you, but they do tell you the rate equation. Okay, remember the rate equation shows you the species that appears also in the slow rate determining step. Okay, so between step 1, 2, and 3, which one is the slow rate determining step? Huh? Hello?
Step 1.
Step 1?
1.
Do you agree? Step 1?
Yes.
Yes. Okay, so that's how you use the rate equation to tell you which one is the slowest step. Or you can do it reversibly. Okay, from the speed of the steps, from the relative rate of the steps, you can write down the rate equation. So you can use them vice versa. Okay, in this case, we're given the rate equation, then we are asked to determine the slowest step. Now, you may be thinking, why is there only 1 molecule in the first step? How does it possibly react? 1 molecule, it doesn't collide with anything. So how does it proceed? It means that the N2O5 is decomposed. Okay, so N2O5 breaks down into NO2 and NO3. So that's the first step, and that is the slow rate determining step. And that's why you see N2O5 in the rate equation. Okay. This is an example of a unimolecular mechanism because in the rate determining step, there's only 1 molecule. Okay. Right, step 1 is the slow rate determining step because the rate equation suggests that a single N2O5 molecule is involved in the rate determining step. Can you please copy this down? Okay, last example before we call it a day. And then the next one, I will just ask you to copy it down. Okay, no, not much explanation because you already know the mechanism of SN1 and SN2. But please make sure you fill in your notes. Okay, I'll send it to you later after lunch because as you know, it's Saturday and I will not say it because this is recorded. Anyway, are you done copying? Ang, are you copying this down? Please don't go out. I cannot. How can I go out? I mean, I can go out, but only to buy food. But I will not say anything more. Okay, that's it already. Okay, if Ang already copied, then I believe everyone else must have finished copying as well. Okay, example 8, using the rate equation, K, rate equals to K, rate constant times nitrogen monoxide square times by hydrogen, and the overall equation is this. Nitrogen monoxide reacts with hydrogen to form nitrogen gas and steam, H2O gas, okay? This equation, this reaction is made up of 3 steps. Okay, step 1, nitrogen monoxide combined with another molecule of nitrogen monoxide to form X. So X is your intermediate here. X then reacts with H2 to form Y. Then again, Y is your intermediate. Y reacts with H2 to form N2 plus 2H2O. So when you add everything up, okay, you can see that the nitrogen monoxide becomes 2. That's why you see 2NO. The X's cancel out, the Y's cancel out. I hope they cancel out. Yeah, they cancel out. So please don't get confused. Step 1, step 2, step 3, that's not the number of moles. Okay, I got confused for a while just now. Okay, which one of the 3 steps is the rate determining step? What do you think? Oh my God, my internet connection is unstable. Please, come on, don't die on me, Zoom. All right, class, step 1, step 2, or step 3? Votes. Who thinks it's step 1? Who thinks it's step 2? Who thinks it's step 3?
Step 2.
Yes.
What's yes? Any more?
Nggak ada, Wak. Apa kan?
Who is that? Who is with Isa?
My sister, miss. She's bothering me.
Okay. Anyone else? Benedict Ang votes for step 2.
Step 2.
Anyone thinks it's step 1? Step 2, Mukrin, Shira, step 2, Ang, wait 1. 2, wait 1. Mirza, step 2. I mean, in
miss.
step 2, there's only X.
3,
Kaisyang
1.
2 as well. No one wants to vote step 1 because step 1 got nitrogen monoxide, 2 of them, some more.
1.
Chun Ang vote
1 and 2, miss.
1 and 2. There's only one slow step in the reaction.
1.
1.
Step 1.
1.
Now you change your
2.
mind. Step 1. Step 2.
2 lang, miss.
Okay, right. The answer is step 2.
2.
Okay, so the rate determining step is step 2. If you say step 1, there's only nitrogen monoxide in step 1. What about the hydrogen? Okay, hydrogen also appears on the rate equation. So step 1 is not the answer. Step 2, you may be questioning. There's only hydrogen, but there's no nitrogen monoxide. Okay, there is nitrogen monoxide, which is in the X. Okay, X, the intermediate X is actually a combination of 2 molecules of nitrogen monoxide. So indirectly, you can see it indirectly that X contains 2 molecules of nitrogen monoxide. Okay, so if you think about X having 2 molecules of nitrogen monoxide and 1 molecule of hydrogen, it follows nicely the rate equation. Nitrogen monoxide to the power of 2 and hydrogen to the power of 1. So step 2 is the answer. Step 3 is not. Okay. Right. So combination of step 1 and step 2 agrees with the ratio that appears in the rate equation. Now, ratio that appears in the rate equation, this is what I was talking about. Okay. X is 2 moles of nitrogen monoxide. That's why we have order of 2 in the rate equation. H2 is 1 molecule. That's why the order is 1. Okay. Right, so that is all for today. You still need to copy down SN1 and SN2, which I will send it to WhatsApp later on. Everyone, you can unmute your microphone now so that I can know if you have any problems or any questions before I leave you quickly. Any questions?
No.
Are you okay?
No.
No
Yeah.
means no, not okay or what?
Yes.
Okay, you're okay. Iqbal, okay?
Yes.
Okay.
Yes. Daffy, is Daffy there?
Yes.
Kawi?
Yeah.
Okay. Mukri. Is Mukri here?
Okay.
Mukri? Okay, okay. Whose voice I haven't heard? Kai Xiang.
Yes.
Okay. L?
Okay, ma'am.
Okay, that's whose voice I haven't heard?
Miss Ravi.
Ang doesn't want to say anything.
Hi, Miss.
How dare you, Ang? Hello, Ang. Is that really Kai Xiang? Kai Xiang, is that really you?
Yes.
Huh? I'm so confused. Kai Xiang? Hello, Kai Xiang? He doesn't want to
Eric?
say anything. Ang?
What?
Oh my God, who is yelling? All right then, if you don't
It's
have
not.
any problem, we should end this session here. Okay. There is a homework for you. I'll let you know. It's not question 3. I think it's question 4, but I'll send it to you later after lunch. Okay. As well as finishing off your notes.
Thank you, Miss.
Okay.
Thank you,
Bye,
Miss.
everyone. Assalamualaikum and thank you. Oh, I forgot to
Waalaikumsalam.
Bye, Miss.
Thank you, Miss.
Bye. You're
Thank you, Miss.
welcome.